right now? That...
Yeah, and it's...
Okay. Okay, so I'm going to start. So hi everyone, this is Ivy, and I will be talking about machine learning today. And this is an agenda. First, I will give a self-introduction and then talk about what is machine learning and talking about some machine learning application in the environment. And then I'll talk about some fundamental concepts in machine learning. Lastly, I don't know how much time we have, but we can do some small activity to practice the concepts like we'll talk about today. And here is about me. I was initially born in Shenzhen, China, and then moved to US in 2017. I graduated from Haverford College with a bachelor degree in computer science in last year. And currently, starting this year, I work as an AI/ML rotation engineer at Apple. And I'm mainly responsible for building two areas. First is building the Siri applications, and the second is to doing ML research for future applications. So it's a combination of engineering and research work. And in general, what is machine learning? Machine learning enables machines to automatically learn from the data, improve performance from experiences, and predict things without being explicitly programmed. This is the first definition when machine learning was coined. And in general, like we are trying to learn from the past and based on the patterns in the past and predict the future. And so how is that different from the traditional like technology? Is that traditionally human used to define the parameters and rules. Like you are given an x and then a human define f, a function, then you want to calculate the output y equals f of x and some other parameters. And but by contrast, for machine learning, we are not giving the function. We are given just a x and the y. We're given the input and output, and machines try to learn the underlying functions f of x and some parameters during the model training. And during the runtime, we give an x and we use the predicted function to calculate the output. So that's a high-level idea of the machine learning. And now I talk about some applications in the environment specifically. There are a lot of big tech companies that are currently like the companies are using trying to use machine learning to do environmental initiative. Like for example, Google is currently using machine learning model to reduce the energy load of its resource-hungry data centers, and also they're trying to do a smart transport to reduce pollution by by monitoring the traffic in real time. And second, IBM is also using machine learning for better weather forecasting and also modeling the impact of the extreme weather events. This can also help the policymakers to make policy in terms of the carbon emission and management. And there's another company called Excel Energy that uses machine learning to predict the energy consumption patterns. And also Carbon Tracker is another company that uses ML to track the emissions using some satellite data. And in the end, like Blue River Technology uses ML to detect the presence of invasive species and other biodiversity changes. There are many initiatives, and here are just a few examples. And to sum up, there are a few areas for challenges and opportunities in the ML in machine learning, ML environments. First and foremost is the climate change. We can try to, in this area, we can use machine learning to potentially optimize the energy generation and also analyzing the energy usage and stuff like that. And also in the biodiversity and conservation area, you can use the satellite image to detect.
Sorry. I'm sorry for interrupting you, but is the slides changing because it's currently stuck on the first slide?
Oh, I didn't actually.
Oh, okay, yeah. Now we see it. Thank you.
Wait, does that not see that? Because I'm.
Oh yeah, it was just on the first slide.
Yeah. All right. Now it's like showing.
Yeah.
Ah, that's interesting. Yeah, maybe I can just go this way.
Yeah.
Yeah. So I was talking about me and what is machine learning, and traditionally human explicitly define the parameters, and traditionally you're given the input and function to calculate the output, but for machine learning, you're given the input and output to learn the underlying function. And yeah, if using application, I just go through like some companies using example, and also for the challenges and opportunities like their climate change, their biodiversity and conservation, and also there's some water issues like predict water usage and use also forecast weather, and yeah, water forecast and disaster resiliency, also healthy air. Like all of the environmental challenges could potentially be mitigated using ML. And yeah, now then I'm going to talk about some fundamental concepts in machine learning. So first is regression versus classification. So these are the two most important problems. Regression basically predicts continuous and real values such as the temperature, age, salary, and price. And as you could see from this chart, the regression model, like they're basically the linear regression model, the outputs can be is infinite. The output space is infinite. It can be in any values. And versus the classifications, they're predicting the discrete values such as male or female, and true or false, and stand or not stand, etc. So as just like you could see here, there are limited amount of outputs that you are given. So output is a finite space. So here is the fundamental difference between regression and classification problems. And here is some, for the regression algorithms, the most common one is a linear regression. We can have a simple linear regression just like this one, where X is, for example, could be the number of experience, and like Y could be the salary, and this is their relationship between each other. And you can use the simple equations where A0, A1 are the coefficients, and there's also an error term. So it's just like algebra that we learned before. And go ahead.
I have a question.
Yeah.
When you mean a regression algorithm, does it mean to like there's an infinite amount of possibilities like in the like in outcomes?
Yes, because your salary can be anything on this axis. It could be any value ranging from like this value to that value. So that means there's no limited. It can anything between this range is can be the output. Versus for a classification algorithm, the output can only be one of the predefined one of the value in the predefined set. And yeah, so the algebra we learned like linear regression, this is actually a machine learning algorithm. So a machine learning algorithm is not that complicated. It could be as simple as a linear regression. And this is a two-dimensional graph where there's only one x, one variable that determines the output. But there could also be multi-variable linear regression where there can be multiple variables that determine the results. And for example, if you want to calculate the profits, and there are several states, several variables that can affect the profit, such as the R&D spend, administration spend, state, and we can also plot a regression formula for the profit. Y equals some weight times this variable, and some weight times this one, and some weight times this one. So this is the most common regression algorithms. And when you are given the x and given the y, the machine can learn the underlying parameters, like what is A0, what is A1, and etc. And we also use the term coefficients, features, and parameters interchangeably, because mathematically it is, or in like algebraically it's called coefficients, but in the intuitively we call them features. So because experience is a feature intuitively, what does X mean? X means experience. So yeah, so there are different ways of describing these things, and this is a classification algorithms. And classification algorithm, like you have it's a logistic regression one, is the most common one, and usually it helps given once you have such a regression output, sometimes people don't want such infinite output space. They just want a 0 or 1. They want to know either. So they usually have this algorithm to map output to a discrete value, such as 0 or 1. And this is the most common, this is a logistic regression formula, which we also call as a sigmoid function. You are given any x, but given any x like that are greater than 0, you are able to use this formula and to calculate probabilities between 0 and 1. And so the input is infinite values, anything on x, but the output eventually, after applying this formula, it can only be 0 or 1. If after this formula, if it passes certain threshold value, such as 0.5, then we output as 1. And if that's below the threshold value, then we output that as 0. So this is this logistic regression model. If you have heard about the fancy term deep learning neural network, it's actually the last layer is a regression, logistic regression formula. If you, after many layers of a calculation, then you get a value, then you try to apply this to make it eventually 0 or 1. So that's the underlying math behind that. And another common one is called decision tree. Decision tree is basically consists of some nodes and some like branches. It's just like a bunch of, it's kind of like a bunch of survey questions. If you want to make like, for example, decision of whether you want to accept an offer, then you want to ask several questions. First, how like, what is the salary like, and is the salary between this range? If that's not this range, then you directly decline. And then if that's in this range, you need to ask another question, whether the office is near your home. And if not, then you decline an offer. And then if this also met, then you also need to say whether it provides cab facility. And if yes, then accept the offer. So there are several conditions. So this kind of decision tree is also based upon like some conditions and like some conditional probabilities, and you use that to calculate the likelihood of some final outcome. And yeah, the benefits of the decision tree is that it's very like interpretable. It's very to see the decision process, but it's also there's some high complexity, which means you want to actually construct this tree. Like when in the coding, it takes a lot of space, and so that's the downside of that. But these are two of the most common classification algorithms. And yes, and now I want to talk about supervised learning versus unsupervised learning. What we talk about, like regression and classification algorithm, are both supervised learning because we have label data sets. By label data sets means like we have a Y for that. Do you remember at the quite beginning I talked about you were given an X, you were given a Y, then you calculate the F underneath. But not all the case we have the label data. We don't know the output of the input. We just know the input. Then how can we do the learning? Then we can introduce unsupervised learning. We don't have the Y, the label data sets, but we can use clustering to split the data into the groups based on similarities. Like here's an intuitive example. You have some like potatoes of different colors, and you don't know the output. You don't know what the color of each potato is, but you know they look different. So you can still, you don't know like what this called, but you can still group them together and by their color and similarity. So this is a intuitive explanation of unsupervised learning. So in industry setting, like or like in actual machine learning research modeling, we definitely prefer to have label data because that gives us more information. But because of all the data collection issues, we don't always have label data. But we need to find some alternative ways to do the learning, such as unsupervised learning, and this is becoming increasingly popular, especially like it's harder and harder to collect high quality data now in the machine learning world. And lastly, I want to talk about some potential issues of using machine learning model. Sometimes you're seeing some very high scores, high accuracy score from models, but that's but that might not be actually reflecting the model's performance because there might be some overfitting issues. By overfitting, that means the model is overtrained and causes a lot of noises, like and undertrained on the other hand is underfitting on the other hand is undertrained. It's not learning enough. For example, you're given the blue points are your training data sets, and a good like a learning like the predicted function is like this red function. You're trying to showing a general trend of this data, but not exact. But for the overfitting, you are literally connecting all the dots together, and you are learning too much. You don't have to learn these details because that can make the performance only reflects on this data specifically. When you are seeing a new data, it's hard for you to predict where that lies because you are overfitting on your training data set specifically. You're not trying to generalize over like a larger amount of data sets. So this is the idea of overfitting and underfitting. Underfitting is like you are undertrained. Like you can see this red curve, this red line doesn't really reflect anything about the trend of the data. And yeah, so when we are doing like machine learning evaluation, it's also important to consider whether there is overfitting and underfitting. Yeah, that can, because machine learning task eventually is to generalizable to different new data. It's not just like performing well on your own on the existing training data. And here are some other statistical terms such as bias and variance. Like if you have a high variance, then you can see the machine learning performs well on the training data set, but does not perform well on the test data set because it's overfitting. It's generalizing too well on the training data sets. And if you have high bias on the if you're under this because you have a lot of prediction errors. Apparently, this has a lot of prediction errors. So these are some like another important concept to consider. And yeah, so to sum up, here are some caveats for machine learning. So machine learning is not perfect. The goal is to make the guess good enough to be useful. So we are not trying to like make sure that every time the prediction is always correct, but we want to make sure that it's significant enough to be useful. And yeah, so that also means if you are solving a problem that requires has very low tolerance for error, then probably you are not trying to consider machine learning because machine learning has a very high chance of having errors. It's really just a matter of how high the error is. And also you might have seen like machine learning builds heavily on statistical math. So if you're interested in machine learning, like it's necessary to have a basic statistic and mathematical background for that. And also the performance of machine learning algorithm depends on the amount and the quality of data and can be determined by the cost function. This is also very intuitive because data is basically what you learned. And just like you are learning as a student, as a human, you need to have a good study materials in order to learn the concepts. And the cost function is defined by the human. And this is something like basically you can like the way you learn, you can like interpret that the way you learn. You need to have a good study material, then you need to have a study methodology in order to learn well. So these are some caveats for that. And yeah, and here wraps up my content. And here I have some small activity that I want you all to think about. Before that, I want to get any questions. Yes.
I just had a question.
Yeah.
How do you get a better quality of data?
Yeah, that's a good question. Actually, getting a good quality data is very challenging in machine learning. Usually, we have some open source data. Like some people have collected good quality data before, and that's for all the machine learning researchers to use. But if you have your own problem that you do not have existing data, then you probably have to collect that by yourself. You can, for example, writing some automatically script to do some web crawling and collect the data, or using stuff like an Amazon Mechanical Turk to help you label the data, depending on what kind of problem you're trying to solve. Some data are easier to collect than the other. Like, for example, for the speech data, it's probably relatively easy to collect because you can just ask your friends, people around you to speak something. Then that's probably relatively easy. But if you want to say something like some data that are not like for example image data, then you need to do a lot of web crawling and processing, and that might be a little bit harder. So yeah, data collection is definitely a challenge nowadays in machine learning. So there are a lot of ways to trying to like use little data as possible to but still have a good performance. Yeah, any other questions? Yeah, if not, then you can still ask your question later, but we can try to do the small activities. I just here are some other applications of machine learning, like for example, in stock market trading, online fraud detection, virtual personal assistant, and stuff like that. And you can try to select one application in the picture and think about one specific problem in the application. And for example, if I say stock market trading, and one of the problem could be what is the price of this stock tomorrow, and yeah, and then you can try to see whether it's a regression and classification problems. So this is the first question, whether it's a regression or classification problem. So the price I just mentioned, price can be is a numeric value, so it should be a regression problem. Then you can think about how the training data could look like. If you were to solve this machine learning problem, you need to prepare the training data, right? So how the training data should look like. For example, what is the corresponding input X and what are the corresponding output Y? And what are some potential features of X that can affect Y? In other words, like what kind of inputs, what are some factors can affect the output you're trying to predict? Yeah, like maybe you can do some small exercise and try to recap on what we just shared about, and yeah, and share that with the group if you want.
Could I just say mine out loud? Or
Yeah.
should I just write it? I just selected the traffic prediction. I think one specific like problem would be just like, I guess, like you can't predict when the accidents will happen, so it has to like show up after the accident has happened, making it like slow to update. I think it's would that go into a classification?
Yes,
No,
exactly.
Okay.
Yeah, because that's what could happen or traffic happen or not. So it's a binary classification. There are two outcomes. Yeah, that's good. And then what about the training data set?
I think it will look somewhat similar to like if you were doing it on a highway, then I guess the accidents will be more frequent. So the input will be more like more cars would equal more accidents, I guess.
Mm-hmm.
And then some features of X would be, I guess, would it be like the amount of road safety on the like highway?
Yep, that's a good one. Yeah, there are many ways to think about this problem. Yeah, you can think about the amount of road safety, and if you are trying to make it a machine learning problem, then that means in your training data set should also define this amount of road safety as a feature. But how do you quantify the road safety? Then there should probably need to be some more detailed matrix on how do you quantify the safety. Do you assign a score for that, or is there any other like sub feature that determine the road safety? Yeah, so they're all important questions to think about. But there's no like a one single correct answer. It really depends on the way you model this problem. Anyone else wants to share something?
It's really quiet.
Yeah, that's a really good one. Yeah, these are really common like machine learning problems nowadays.
I have a question for self-driving.
Yeah.
How would you classify that?
Oh yeah, self-driving cars is like yeah, I think you mean like what do you mean by how do you classify that? Like,
like what? How do you know if it's a regression or a classification problem?
Ah, I see. I think it's definitely self-driving is a huge field, which is why I said you should narrow it down. You should select one specific problem. Like for example, the one you just said, whether there could be accident or not, that's definitely one problem. And also your actions, like whether under this situation you should turn right, turn left, and stop. And this is also one problem, like a classification problem. I think self-driving cars in most cases should be classification problems because you need to teach because the machine itself is just a car, right? You need to teach the car what action to take under certain scenarios. So I don't think there's really any apparent regression problems within this area.
It's really cool. Rishita asked a question in the chat how machine learning will detect whether an email is spam or not.
Oh yeah, that's then you need some training data for that and for example, usually this falls into a field called natural language processing, and you need to have a lot of training data. Some training data are labeled as spam, some training data are labeled as non-spam. Then the machine will like try to. So there are a lot of pre-trained language models nowadays. Like they can help you analyze the underlying patterns of those tags and see what features are usually associated with spam. Like what, for example, there might be some keywords and some way of phrasing, and that can classify spam. And also, in addition to the text of the email, the sender of the email could also be another feature. Like if that person apparently coming from a spam look-like organization, then that's also one way that can affect the predicted outcome. So it really comes down to how your training data is like and how you featureize, how you select the features of this problem and of this spam classification problem. Yeah, so for what I can think about is a sender of the email and the content of the email. I think these two are the major ones. And maybe also from the recipient side, whether you have blocked that person and stuff like that.
Someone else asked a question. Akriti asked, diagnosing diseases or narrowing them down based on only symptoms, would that be regression or classification?
You mean the medical diagnosis?
Yeah, depend on symptoms, like based on only symptoms.
Yeah, I think that should be the classification problems because you're outputting the output is a symptom, and the symptom is a limited amount of symptoms, right? It's not like usually when we say regression problem, it's some numeric values, and it's not a category. If that's a category, then that's usually a classification problem. If that's a numeric value, then there's an infinite amount of possibilities. Like stock market trading is one because the price is a regression. And let me actually think about is there, and I think most here seems to be classification. Traffic prediction might be regression if you want to have any quantify the traffic in some way. And yeah, I think most here image recognition, that's speech recognition. These are definitely classifications. And product recognition is also a classification because you're recommending a specific product and this limited amount of like choice. Language translation. Yeah, language translation is actually an interesting one because you can, when you say language, you can think, oh, there are a lot of different languages. How can you, that seems to be as many as the numeric values, but actually it's still classification. You need to have a huge vocabulary space as the output, and you select one of them. So just like right now, I have done some question answering research, and you are trying to predict an answer by retrieving from the answer from the like web. Yeah, there are so many answers. There are so many phrases, vocabulary, but still it's a classification problem. But it just like it's a class, the potential class size is super huge.
Wow. Another question that we got in the chat is if machine learning algorithm is able to be applied in detecting if a plant is having a disease by like scanning through cameras. So basically like a project for plant diseases, like a detection system. Is that a possible thing?
Oh yeah, I think that's definitely possible. But it depends. It depends on like yeah, I'm not too familiar with the plant disease like biology for that. But if you can have any way to input the features to the machine learning models, then that's definitely possible. For example, the input could be the image. If you can just by looking at the plant, then see whether it has a disease. If that's doable, then that's definitely possible because as long as you have a good amount of training data. And yeah, image, yeah, you can input the image of the plant, or it could also potentially be some sensor data, converted that into a sensor data instead of image data. Like for example, we can let the machine feel the plant in some way, and that's also a possibility. Yeah, it's definitely possible.
Are there any other questions or ideas to pitch in? So tons of pictures with plants with diseases will be needed, right? In like a follow-up to that.
Yeah.
Cool. So a few more questions. So, self-driving cars can make decisions. So is it like they use reinforcement learning, or how does that work?
Oh yeah, reinforcement learning. I think it's a major algorithm. Because you need to, as I just said, the major problem of self-driving car is to determine what action to take under what scenarios. And reinforcement learning basically is the idea that you have some actions, and then you need to calculate the reward of a single function, of an action under a certain scenario. Like when you are in this situation, then you need to look at your surroundings to see whether, for example, there's a traffic light, whether there's a stop sign, whether there's a car and besides you, whether there's passengers, and you need to like look at so many different information, just like you drive as a human, and then based on those information, then you like do those prediction calculation and determine what is the best action to take. That's also that was trained using reinforcement learning, and then after calculating the rewards, then you like for example, when there's a passenger, then the reward to stop is high, the reward to go is low, and then in that case, you know, okay, I should stop at this point. Yes, and yeah, so in general, that works is that you have a sensor to like receive all those data around you, and then you need to process those data. You need to have a machine learning models, and then to predict the right action to do at this moment based on those inputs.
Cool. Another question was, more questions. Can you suggest a learning path for someone who would like to start machine learning journey?
Yeah, so definitely like first study the basic, like take some machine learning class and to understand the basic concept, and then try to either do some machine learning research or doing some machine learning project. And I think try to get, yeah, by research or project, that means you're trying to select one problem you're interested in, and then try to find some data for that, and try to use some simple machine learning model and train the data, and then see if you can get some good results with that. Yeah, just try to do some small project. First learn the concept, and do some small projects to get some experience with that. I think that's a good way to get started. And for me personally, I really like to watch a lot of news and articles related to machine learning. I like to keep an eye on the latest trend in machine learning, the latest applications, and also the most state-of-art technologies. I think those are really interesting. And yeah, if you're interested, you can also subscribe to those like articles and yeah, YouTube channels.
And the question was, can machine learning detect whether an object is hot or cold?
Oh, then that requires sensor data. Like the sensor data means like you can actually feel the object, and then you need to then that no, not sensor data. I mean, like there is some way to I forgot the exact physics term, but you need to like you need to detect the temperature of that object and then convert that into a like raw data and then receive that raw data and process that. I think it's sensor data. Yeah, you sense that data and then, but it's not the temperature is in it's 0 parameters or something. I forgot the name, but yeah, it's physics related problem. It's definitely possible. Yeah.
Great, thank you. What are some best projects according to you, which you would suggest to a beginner in machine learning?
The most if you watch some machine learning tutorials, the most common one is to classify whether a animal is a dog or cat, and there's a lot of data sets like that. And so just try to find existing data sets and existing good data sets and try to build a simple classification models like that. By the classification model, you can use like, for example, decision tree, as I mentioned. Yeah, decision tree, like I mentioned here, or some such just some off-the-shelf machine learning, or just try to use existing machine learning model and try to give your own input and see their predicted outcome and play around with that. Yeah, that's one way to start. Like find existing data set and existing tutorial, try to follow step by step and see if you can reproduce the results. If so, then you can try to gradually become more creative and try to build your own model.
Thank you.
Yeah.
Does anybody have any other questions? Feel free to either speak up and put in the chat, or and I can read it out loud. Ooh, what are the main differences between AI and machine learning?
Oh, machine learning is a subfield of AI. So yeah, it's very similar. People use these two terms interchangeably. AI is a broader term. And when we say machine learning, there are also some ways like deep learning, reinforcement learning. But in my opinion, they are all machine learning. So it's really no major difference.
Oh, that's really cool. I never thought about it like that way.
Yeah, some people like to use deep learning and reinforcement learning and instead of machine learning, and they all fall into AI. But for me personally, they basically mean the same thing. Like, yeah, AI is probably more generic and less messy, and machine learning is more like technical term for that. Like because using machine learning, it's more technical and a lot of math and statistics. But AI, when you think about AI, you think about more about its application products. So that's my understanding. Like 2 coins answer. Feel free to search on confirm.
It's really cool. So there are a few more questions. May I know how do we build a data model?
Data model. Do you mean machine learning model or?
Yeah, I believe they mean a machine learning model, like a data model for machine learning.
Okay. If you want to build a model, so so the machine learning model you can build from scratch or linear regression model. This is very easy, and decision tree. I think you can follow some tutorials, and basically you need to implement a loss called I think called entropy loss. And there's a loss function for decision tree. You can implement that from scratch as well. Just follow some tutorial. And logistic regression as well, the the function is just like this. It's very simple. You just implement the math there. But for deep learning neural networks, that's a lot harder to implement from scratch. That way, you usually use PyTorch or TensorFlow or Hugging Face to import those pre-existing model, and you just basically adjust some parameters for that. You don't build the architecture from scratch. And also, when I was taking machine learning class, there's also like k-nearest neighbor and SVM, which stands for support vector machine. I think those are someone that you can build from scratch. As long as it's not neural network, you can usually build from scratch. Just follow some tutorials and figure out the underlying math behind them. You should be good.
Thank you. So then the next question. Oh, go ahead. Go ahead.
How would you like implicate the algorithms into like a machine?
You mean how to feed the algorithm into the machine? Yeah, you can just implement that code the algorithm. Like for example, for regression, linear regression, then you define the underlying algorithm for that. In how do I explain it? Yeah, you can just code in Python, and then you have a if you have the function, then if you have this function implemented, then that's essentially a model. Yeah, if you're talking about like PyTorch or TensorFlow, that part, you follow their tutorials, and once you train a model, then they will save their model into a file, and then you can import that, then load that, and then run the prediction. Yeah, you can just follow the TensorFlow PyTorch tutorials. Yeah, yes. I don't know if that answers your question.
Yeah, it does.
Okay.
Another question was, can traffic prediction, image, and speech recognition be applied all together in self-driving cars, or would that change the initial algorithm used in self-driving cars?
You mean traffic prediction and what else, sir?
Image and speech recognition.
Oh, yeah. Oh, definitely. These are all of these three are I believe are sub problems of self-driving car. They are used interchangeably. They have a lot of overlap. Like for example, in order to for the first part, you want to the first part of the pipeline, self-driving car pipeline, is a perception part where you take the sensor data, like the surrounding and surround you, as I mentioned, and you need to do the object detection. You need to receive the you need to detect the 3D objects or image, 2D object, 2D image. And that part is image recognition. And then you need to, based on this, you need to see what action to take. And I don't think it will change. It will change the initial algorithm because they are part of the pipeline anyways. Yeah, image recognition or sensor data recognition is the first step. And then based on the image recognition results, the output of the image recognition becomes the input to the next reinforcement learning algorithm, as I mentioned. They're different part tasks they're building next to each other, and in order to do the end-to-end self-driving part task. And so they're definitely very related. And for the speech recognition, I believe if the surrounding data, if there's any horns and stuff like that nearby, then you need to recognize that as well. And yes, and there's no single way of building the self-driving car pipeline, but these components usually are part of the task in the self-driving car.
The next question was touching back on a previous point, asking if machine learning is like a subset of AI, basically.
Yeah, it's a subset of AI.
And then a question after that was, if those are photos collected as data that you showed in a previous slide, tables and graphs are not applicable, right?
Sorry, which slide are you talking about?
I'm not sure here. It said, I'm thinking in regards to the data model question asked earlier, if photos collected as data, tables and graphs are not applicable, right? That's what the question is.
Oh, if that's for, no. Your data, your input data your collected data could be anything. It doesn't necessarily be image. It can also be graph, and yeah, it can be anything. Depend on the problem.
And then the next question was, do we need to be an expert in Python to deal with machine learning?
Oh no, definitely no. But you have to be familiar with Python at least, because most machine learning model training and scripting is done in Python, and yeah, you have to be familiar with you have to be comfortable, I would say, of coding in Python. And you don't have to be expert. I don't think I am an expert, but I'm comfortable in coding Python.
And then this asked, how does identifying between dogs and cats in a picture work? How does machine learning distinguish between the both?
Oh yeah, so image that falls into the image processing or computer vision field, and that's also part of the machine learning. And usually, image works by pixels, and all the images are like there are 3 dimensions. The first the first 2 dimensions are the pixels, and like how many pixels do you have, and then there's a color is another dimension, and color is determined by the RGB value. And then you need to analyze that pixel by pixel and see for the cat or for a dog, what kind of pixel usually have the curve of the dog. Like for example, some cats, their ears and are on the head, right? Like the dog might like be down, like some feature like that. They'll analyze. They won't interpret like as human to see, oh, where's the ears, where's the tails, where stuff like that. But they will look at that pixel by pixel, which pixel mostly likely to have the ear, and given image of the same amount size. Yeah, that makes sense. Like for example, this pixel might mostly have the ear if it's a cat, but that pixel most likely have ear if it's a dog. And yeah, that's how the machine learning used to distinguish.
And then I'm not sure if this I think you basically kind of answered this, like how to convert photos into data. So I don't think you really need to, do you want to go? I don't think you really need to go more into that. But the next question was like, which language would you suggest would you suggest like Java or Python?
Oh, Python. I don't think after graduating from the college, I have ever used Java in industry, because I mostly, as I mentioned, I mostly work on machine learning research, and this one primarily use Python. But for building Siri application, it's mostly iOS application, so I use like Swift, Objective-C, and C++. I don't really use Java. So if you're interested in machine learning, I would say definitely be comfortable with Python first. And Java is probably not directly helpful for machine learning. That's my suggestion. But if you're interested, but it definitely help you with your computer science programming skills in general.
Thank you. Does anybody have any other questions? Feel free to also just ask up, like unmute and go. Is that it? I can send some resources as well in the chat.
Yeah, feel free to share my slides too.
Sorry, yeah. I shared that as well already. So cool. I believe that concludes the session time. Does anybody have any last questions? I think that's Thank you so much, Ivy. This was an amazing session. Really loved it. I personally learned a lot as well. And yeah, I'm sure many also learned a lot. And oh, excited. Okay, cool.
Thanks for the invitation.
Thank you. Yeah, thanks everyone who attended. So great to see all you guys' projects. And if we have any machine learning ones, I'll definitely let you know, Ivy. See
Thank you.
Yeah.
everyone.
Thank you.
Bye.
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 I will put these resources in the Discord as well. Cool. All right, so everybody here, the session has been finished. And there are no more sessions for today, as for many people it's already time, but the next session is tomorrow for some people, I guess. So let me view it. The next session,
11 a.m. EST tomorrow.
Yeah, it's
for,
tournament.
yeah, but
So
it's 8:30 p.m. IST for some people today.
yeah, so we'll be having a little quiz tournament, and then after that, that'll be some fun. Have an open Q&A session at like 12 p.m. EST tomorrow, and then we'll be learning about computer models and sustainability after that at like 1 p.m. EST, and then sustainability, and then we'll learn a lot more. And we'll also learn a lot about, and then on that following Sunday, we'll be having a Scribble.io tournament, learning about Python and app development, learning about sustainability and AI, and then we'll also be having a web development session, 5 p.m. EST on 8 p.m. EST on tomorrow, Saturday. So great weekend of coding, and each of these workshops will all send resources and the links to all the stuff. So cool. All right, this meeting's gonna end, so I'll see you all next time. Bye, everyone.
Bye.